Hello everyone, I'm Shogang. We'll quickly finish off this last little bit of content. And similarly, we'll follow the Emily suggested in our standard project's specifications. And actually we can have an input here. Okay, good. Here we have this FBP thing, and we'll open it directly. Then we specify our BP, and we directly input all. We can see that everything seems to have failed here. The reason for the failure is not clear. Let's try again. Okay, I'll fix this issue. This might be because our engine version is too new. If you just drag one in like this, just drag an asset and do it this way directly. Here, I have a folder to drag over here. Because I noticed it's throwing an error. Let's specify this. It just gave an error, right? Don't be afraid of errors. It imported successfully, sorry. This is a bit awkward. It's because I checked this option. I cheated. If you don't check it, then when you import it, it will give an error. And don't be afraid of errors. We just need to look at the log. It says this. The length of this animation doesn't quite match the import frame rate. It seems incompatible. So how do we handle this? You need to re-import the animation settings. Either you enable this find to the nearest frame border, this import option. So it's very simple. We'll just follow what it says. This might be from the engine. Our case is an older one. And this engine is the version is relatively new. Because you know the engine, each version has major changes. Okay, so here, we've already got it done. Let's remember to save everything. You will see, right? This idle barely moves. And then this one, it just shakes a bit. And then this loop, it also barely. And then this JumpStart also tilts. And then run also tilts. It's hard to tell. So let's not worry about it. We'll just follow this logic. And then here we create our animation blueprint. For the animation blueprint, we need to select the parent class here. Actually, there are many things we can do here, but we won't go into detail because it's the animation part. For the app, let's just call it FPS. Okay, so it's FPS. Okay, so with the animation blueprint ready, we need to start implementing the logic for our animation blueprint. First, we add a variable that we need to use for judgment right here. Well, we won't go into details about thread safety or anything here, and interfaces are too complicated. Actually, those belong to advanced animation techniques. General Emerson T. Ace care a lot about this. You can check it out on Bilibili. There are actually many animation experts there. They often share some things too. All kinds of procedural animation stuff, but we generally can't use these yet. Then note that you just need to double click here. There are actually some other functions here. You can see there's an init. Let me take a look. Yes, there is actually an init here, but you would do it this way. You sometimes like to do it this way, but I advise you not to do it this way because it can cause some problems. You sometimes do it like this. Then next, you go ahead and use this variable, but sometimes it may not be initialized successfully. So I don't recommend you do it this way because it will cause some problems. It will have some potential issues. These are some small tips from experience. Render insert all, we can just paste it directly like this, because this seems to be a major feature. After the U5 update documentation, you can just paste it directly. Actually, in our daily development, you can paste these blueprints. Let's copy them. Let's find the desktop here. Let's create a new txt file. You can see that actually, right, this is our blueprint. It might look a bit uncomfortable, but it is a blueprint. Blueprints can be copied between each other. Lower versions can generally be copied to higher versions. A bunch of blueprint nodes, but blueprint nodes from a higher version, if you copy them to a lower version, the connections will break. You'll have to reconnect the wires. This is a very painful process. So during plugin development, we usually start developing from the floor door. This is a basic piece of knowledge. Then we get this character. This is usually successful because At this point, what we need to do is to get our character movement. Then we can just paste it directly. There's no problem with this. Obviously, this place doesn't seem right. That's because we missed a node. Because we need to get the movement first. Before we can get out movement mode, you might be wondering how exactly this place works. You can write it this way too, but if we can stick it here, we can save a bit. Then it will be fine later. Usually variables are below. You can see that this is actually the node. And then you can see it's this one. You can see the actual technique. Just to make a judgment. Like equals here. We make it equal to, here we need it to equal an enum. So we need to go through the one above. That way we know what it equals. Otherwise, you'd have to look it up. You'd have to look it up once. So visit like this. Okay, visit like this. Let's align it like this. If we are equal to this following, okay, then we just promote it to this variable. Set this following value. Then next, we continue to set following to true. Otherwise, we don't need to check here. Just set this value directly. Next, we get this speed. For speed, we can actually get it directly from the character. We can do it like this. Get velocity. Then we set this as a Kajma function. You can see Kazma. Right. Here we can see. Here are some functions, and its function name is vectory_lens. Actually, it will reflect a double floating point value. The input is a factor, and it's called Kazma's math library. We often use this in many cases. You can double-click to jump here. No issues here. Then if it is greater than 0, these blocks are greater than 0. We consider it to be in this. Let me align it like this. Yes. Let's set up a running like this. Okay, good, no problem. Then after this part is done, we can go ahead and create our state machine. Remember to compile and save from time to time. It's fine for now. If you double click this position, when you create a control loop, debugging might cause a crash. Then here we directly enter state machine. State machine. We need to create a state machine. And as for the name, we can call it arms is the state of hand movements. Then trust. Okay, so with it, we first connect it to the monster. Then we write further logic inside here. Good. Of course, here, it will prompt that you don't have this pin. This is very normal. Then similarly, we add a state at this point. These are some aliases, or some conduit, or something like that. We only need to use one state here. So we write this state, that idle. Then let's write down all the names first. Then connect them one by one. Okay, these are some state machine concepts. You can check out our blueprint tutorials, or just search on Bilibili. These commercial blueprints, they are all available in this open project. We won't emphasize this here. Okay, so now we have this kind of state. Then we'll connect it next. Then after we enter, first look at it. It must be is it an idle state? Then here, idle and run will transition. How should the code inside idle be written? Actually, you can directly here. Enter the idle state. Then the animation we need to input is here. Okay, let's compile it. At this point, there should be no problem. Okay. Then it's worth noting that we have many complex state machine techniques, but I won't talk about it here. Okay, this place. One of its transition conditions is that we consider, that is to say, it is a. Okay, as long as it is in the running state, we can let it be considered. Let it directly transition to the running state. How does it go back? Actually, we simply reverse it. That is, if you are not in the running state, then go back. That's very simple. At this point, a basic transition can be completed. Then we start working on the jump transition. As for the conditions for this jump transition, actually it's just constantly following this variable. Actually, right here, if we are in this following state, we prove that we are now in the air. We were originally on the ground. Suddenly falling into the air proves we have jumped, then that's fine. Similarly, this run is the same. We can paste this over. It is also constantly, for in this state. Okay, after we jump, we need to play our jump animation. As for the jump animation, it's just the JumpStart animation. Obviously, we forgot a run here. Let's put this run animation in. So let's add these two animations as well. This is an animation for N, right? Just connect it. Okay. So after we finish jumping, after a period of time, How do we transition to this loop? Actually, it's very simple. We need to use a function like this. Let's compile it first. The transition condition for this. We have a transition condition called getInstant. We need to type it here because some conditions here are quite hidden. GetInstance. Let's take a look. Or we can just give it a player. Or we can just paste it. This is generally an invalid node. Let's see how to handle this issue. Here, we should get the remaining time of this previous animation playback. The documentation here seems not very accurate. Actually, it should be like this. We should directly output FPP, then JumpStart, then input this. The text is correct. This time remaining, JumpStart, such a time. Then, when this time is less than or equal to 01, we believe that its JumpStart animation has already finished playing. We let it transition to this walking loop animation, then continue with the walking loop. We let it transition to NT. The same logic applies. That is to say, we might stay in the air for a long time. So when we are in the airborne state, that is, when we land on the ground, we need to play this landing animation. So here, just do it like this. Then how do we switch the landing animation to the idle state? Obviously, we will still use this here. An end judgment of the animation time. Just compile it like this. It should still be here. We need to count FPP here. There seems to be a problem here. It should be here. We connected this animation incorrectly. So there will be a problem here. That is, it should be end. Only after you connect end here, will you have this here. FP time relying. The remaining time, when this remaining time is also less than or equal to 0.1. Then let's do a simple transition to the idle state. So after it enters, it will immediately switch over. Okay, at this point we have finished connecting. Then go back here. We find our character. We assign our animation blueprint. Obviously, we just need to assign it. To assign it, we assign it here. Hot. Okay, now let's take a look at the effect. There seems to be a problem with our animation. Let's check what the reason is. This hand doesn't seem quite right. This hand is not quite right. It seems because of this part of ours. There's a rotation issue. Let's try to adjust it. Look, this one isn't right either. Let's try to reset it. The position here doesn't seem right either. Let's just move it a bit. Move it down. So we'll just adjust it casually. Like this. Let's try it again now. Look, when it jumps, it will have an obvious jumping motion. This is a small detail, so we've actually finished explaining this small example. But we can open a multiplayer one. Let's save it first. It sometimes crashes. Let's open this mode. We can take a look. We should also have a thought here. And actually, there are two objects in our scene. This is fine. You can see. Right. And it is moving. But actually, you cannot see the ball. You'll find this very interesting. Right? You can't see the ball. Which object are we controlling right now? I'm a bit confused too. Let's control this object. This object here clearly has a small issue. As was these issues, we could actually do some simple processing. But we won't discuss that now, because it involves online game development. Yes, because it involves some components in the scene. They have some synchronization rules, some network synchronization stuff. Alright. So, here's our first small case for you. Well, it's pretty much done. That's it for now. Then, basically, later on, we will gradually teach you more advanced knowledge. The basics should be more or less covered. We'll supplement it later. This variable timer actually from our log assertions, then to smart pointers and multi-threading, and then online game development. This knowledge will be relatively online. These timers and delegates, these will gradually become a bit difficult. Then if you follow along with the videos and the documentation, so everyone should practice more, watch the tutorials. Generally, watch them once or twice, and you'll basically have a concept if you're doing it yourself. 2 to 3 times, and you'll generally be very proficient. Actually, we've already written a lot of code. Take a look at this class. This project should already be. Actually, there's just a small bit of ocean code, plus our previous 400 million project. Okay, so this small case chapter should probably end here for now. Thank you, everyone.